Hi viewers, welcome to LMS Solution. Today we are going to see about how to implement multiport converter for integration of renewable energy sources in DC microgrid application. Thanks for watching our videos and kindly subscribe our channel and also click bell icon for notification of our upcoming videos. So this is the model created for integration of renewable energy sources with a multiport converter. So here you can see that it having solar PV source and then wind energy source, and then it having battery and a supercapacitor. Okay, so and it also having load, DC load. Okay, so it consists of port, right? Port 1, port 2, and port 3 and port 4. Okay, so here there are 3 input port and one output port, so it is known as multi-port converter. Okay, here it having 3 switches, right? Switch S1, S2 and S4 or S3. Okay, so this S1, S2 going to be controlled based upon the MPPT of the PV panel, and then this S4 going to be controlled based upon the MPPT of wind energy conversion. Okay, so this going to be operated in the 4 modes. That means without any without power from the PV and wind energy conversion. Okay, so it can operate without PV and wind energy conversion model. That means the DC load when we get the power from the battery and the supercapacitor. Okay, and then we can operate this model with the PV, battery, supercapacitor and load without considering the wind energy conversion element. Okay, and also we can operate this same model with the wind energy conversion model, load, battery and supercapacitor, and finally we can operate this same model in with PV, wind, supercapacitor and battery and load. Okay, so these are the possible combination of mode of operation of this proposed or multiport converter. Okay, so this is known as P and MPPT. So P and MPPT used for extract the maximum power from the PV panel. So here I am going to explain the PV panel detail. So here I consider only 48.16 watts PV panel. Its voltage in maximum power point is 17.2 and current at maximum power point is 2.8. And then here we model that PV. Okay, so PV operated at 50 volt and the rating of current is 3 amps. Maximum is going to be operated at 3 amps. Okay, and then this is battery detail. So battery having 36 volt nominal voltage and rated capacity is 32 Ah, and here we are using lithium ion battery. And supercapacitor detail, the capacitance value is 9.6 farad and rated voltage is 40, and then initial voltage we are considered is 36 volt. Okay, this is load, so load I'm here considered 50, and also we have another load 50. So this going to be added based upon our command signal, right? So here we given some command signal. So initially it will be off from 0 to 2, from 2 to 4 it going to be connected with the system, from 4 to 6 going to be disconnected from the system, and then after 6 is going to be connected with the system. So we can choose this load, right? We can add this load to the system, so based upon this logic. Okay, so now I am not included this load to the system, we only consider this. So 50 ohm resistor is connected in the system. Okay. So here you are measuring the PV measurement, and then you have to measure PV voltage and current. It will be processed via P into MPPT, and it will generate duty cycle, and then finally is processed via PD loop generated. It will generate the pulse. So this pulse will be going to be given to the switch S1 and S2. Okay, and then same way we are going to measure the wind energy conversion model current, and then voltage across that wind energy conversion model. So that going to be given to the P and MPPT. It going to be generate the pulse, and going to be processed via PWM generator, and then it going to be generate the pulse. This pulse going to be given to that switch S4. Okay, now to extract the maximum power from the wind energy system. So now I'm going to operate the model. I'm not going to consider the PV irradiation. I'm going to make PV irradiation 0, and then on the current injection from that wind energy conversion, I'm going to consider 0. Okay. So the system going to be operated only with battery and supercapacitor, and also I'm going to change the load. So every 2 seconds I'm going to change the load. That means I'm going to add the load. I'm going to disconnect the load, and then I'm going to check the response of the voltage across this load, and then the current in this inductor, right? And then I'm going to consider the supercapacitor current and battery current. Okay. So now I'm going to simulate this model. So this is mode on operation. The mode on operation, that means load receiving the power from only battery and supercapacitor. So here you can see that this is the voltage across load, right? And then this is inductor current of this converter. Okay, multiport converter. So this is supercapacitor current and the battery. So here you can see that this one is battery current, this one is supercapacitor current. So the load receiving current from the battery. Okay, so we will check after 2 seconds load going to be added to the system. Yeah, now we can see that during adding of load, right, what happened? The supercapacitor tried to supply the power, and also you can see that after some time the battery going to supply the power to the load. Okay, so this is because of adding of load into the DC microgrid. Okay, so we will check after 4 seconds. During 4 seconds the load going to be disconnected from the system. So during disconnection of load, so we will check the response of the system. So because of disconnection of load, what happened? The supercapacitor going for charging. After some time, it comes to 0, and then battery current you can see that is decreased from this point to this point, right? Because load is disconnected from the system. Okay. So during adding up the load, what happened? Supercapacitor discharging and battery also discharging, because here we have only two sources, battery and supercapacitor. Here you can see that during disconnection of load, the supercapacitor going for charging mode, and then battery current, discharging current will be decreased from this point to this point. Okay, so at time of 6 seconds, right, again we are going to add the load into the system. So we will check the response of that supercapacitor current and the battery current. here you can see that because of adding of load, what happened, the supercapacitor trying to supply the power, so that's why it will have some this spike in the current, and also after some time it goes to zero, and then battery is going to be supply the power to the load. Okay, so this is the operation only with the battery and the supercapacitor in the multiport converter. So next I'm going to explain, I'm going to operate the system with considering PV panel, battery, supercapacitor and the load. So here I'm going to make load is constant, right? And then I'm going to change the irradiation for every 2 seconds from 1800, 600, 400 watts. Okay, watts per meter square, and then we will check the response. So here you can see that this is irradiation, this is PV current, so this is voltage across the DC load. Okay, and then this is known as current of supercapacitor and the battery. So now one more source, that means PV source is added into the system. Okay, so we'll check the response of the system. So here you can see that supercapacitor in charging mode, battery in discharging mode. Okay, now you can see that PV after 2 seconds and the radiation is reduced to 800. So because of what happened, the PV current is decreasing. So because of decreasing PV power or PV current, what happened, the supercapacitor discharging, and then battery current is increasing. Okay, so after at the time of 4 seconds, again the irradiation reduced to that means 600 watts per meter square. Because of reducing irradiation, what happened, PV current going to be reduced. Okay, so we'll check the response of the supercapacitor current and battery current. And also here you can see that this is a oscillation of DC load. That means small oscillation will be occur during that change in irradiation condition of the voltage of the DC load. Okay, we'll check at the time of 4 seconds. So now you can see that because of reducing irradiation, right, the PV current is reduced. So because of the what happened, the supercapacitor discharging for some time, and then battery current is increased. Okay, so this is the working of system with PV, battery, supercapacitor and load. Okay, so next I'm going to make PV operation 0. So we are not connected the PV system. Now I'm going to connect the wind energy conversion system. The current reference we are given is 0, 1, 2, 3. Okay, so we are increasing the current, right, from 0, 1, 2 for every 2 seconds, and then we are going to take the response of the, that means scope response of the system. That means we are going to analyze the voltage across that load, and then current from that wind energy conversion system, and then the current of the supercapacitor and battery. So initially there is no power from the wind. Okay, from 0 to 2 seconds. So here you can see that this is sharing of power, that means current from the supercapacitor and battery to the load. So at the time of 2 seconds, wind energy conversion start to supply the power of 1 amps. Okay, so here you can see that the current increased here, right? So wind energy conversion system starts supplying the current. So because of increasing current, what happened, the supercapacitor going to charging mode, and also the discharging current of the battery goes to 0. Okay, that means the total load is fully supplied from the wind energy conversion alone. Okay, so we'll check after 4 seconds, because after 4 seconds we are going to increase the wind energy conversion power from 1 amps to 2 amps. So we will check the response of the system after 4 seconds. So now the current increased to 1 amps to 2 amps. So because of that, we can see that the supercapacitor is charging for some instant, and then battery goes to charging mode. Okay. So now we can see that the wind energy conversion system is fully supply the power to the DC load as well as to charge the battery and supercapacitor. So this is an operation with the wind energy conversion, battery, supercapacitor and load. So next I am going to operate that means I am going to connect the PV panel, wind energy, battery, supercapacitor in this system. So now the system is operated with the all sources. Okay. So here I am going to change the radiation from 1000 to 500 at the time of 3 seconds. And also here I am going to change the current reference in the wind energy conversion from 0 to 2 amps in the 5 seconds, and then we will check the response of the system. So here we are going to measure the current of IPV, wind energy conversion current, and the supercapacitor current and the battery current. So here you can see that. So this is a current from the PV panel. So this is a current from the wind energy conversion. So this is a supercapacitor current and the battery current. So after 3 seconds, we are going to decrease the irradiation of the PV panel from 1000 to 500. So we will check the response of the system. So now battery is discharging, supercapacitor is here it goes for charging and comes to 0, right? We will check the response after 3 seconds, because in 3 seconds the PV radiation is changed from 1000 watts per meter square to 500 watts per meter square. Yeah, now we can see that. So because of reduction in the PV, right, what happened? The supercapacitor goes for discharging, and also battery is charged. That means discharging more, right? So because of reduction in the PV, so supercapacitor and the battery goes for discharging. Okay. So now that means in 5 seconds I'm going to increase the wind energy conversion current from 0 to 2 amps. Okay. We will check the response of the system during increasing power level from the wind energy conversion system from 0 to 2 amps. So now you can see that. So here the current is increased from 0 to 2 amps. So because of that, what happened? The supercapacitor will charge instantly for particular time, and also battery comes to charging mode. Okay, because now the PV and the wind energy conversion having more power to supply the load as well as to charge the battery as well as supercapacitor. So this is working of multiport converter for integration of renewable energy sources in the DC microgrid application. Thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you so much.